All right, I think we're going to get started. Welcome, everybody. I'm Doug Davis from IBM, one of the co-chairs of the Serverless and CloudEvents Working Group, and we have Cathy.
Yeah, my name is Cathy Zhang. I'm a principal architect at Huawei, based at Silicon Valley, also part of the working group.
All right, I'll present the first half, and then I'll hand it over to Cathy. So what we're going to talk about here today is the Serverless Working Group within the CNCF, as well as the CloudEvents project, which is a spin-off from the Serverless Working Group. This session is strictly a high-level overview of the topics. We do have another deep dive session tomorrow. We'll show you the time later in the slides, but we're not going to dive too deep here, just give you a cursory introduction to what's going on in these various working groups. Then Cathy and then Clemens, another member of the working group, will go deeper dive tomorrow, just to give you a heads up. All right, so here's a quick agenda. Go over the Serverless Working Group, CloudEvents, a little bit of what we're doing there in terms of other ancillary pieces of work like SDKs, workflow, and that kind of stuff. And then, time permitting, we may have a demo for you, but we'll see how that goes. All right, so Serverless Working Group. I believe it was middle of last year or so, the Technical Oversight Committee in the CNCF decided they wanted to have an investigative group set up to figure out what's going on with serverless. What is serverless about? Who's using it? And for the most part, kind of decide whether they actually wanted to do something with serverless at all, or whether it's not a technology that they should care about. So what they did is they formed the Serverless Working Group to go off and do some investigation. And for the most part, our purpose was to produce a white paper, which was to provide an overview of the technology, provide sort of a gauge of what's going on in the ecosystem, who's using it, is it becoming popular, how are people using it, what are the valid use cases, stuff like that. Just, like I said, just provide an overview of the technology. And then finally, we ended with some recommendations of what the CNCF might do going forward. And some of those recommendations might have been do nothing. We'll talk about what those are in a sec. The other thing we produced was a landscape, which is pretty much just a statement of what's out there in the ecosystem today. What are the open source projects out there? What are the proprietary projects out there? What kind of services hook into serverless frameworks or functions as a service? Those kind of things. And so basically just gave a lay of the land related to serverless and functions as a service technology. Now, I mentioned earlier we had a set of recommendations for the CNCF, or the TOC in the CNCF. Well, one of the recommendations was to look at something that we can look at from a standardization perspective, right? What may there be agreements within the community on that we can all come together to produce a single form of something, rather than trying to continue to have different sort of syntax views of the same kind of thing for the most part. And what we came up with was events. We realized that functions as a service and serverless is really, for the most part, in a lot of cases, about eventing. So can we find a way to sort of standardize the events themselves coming into the system so people can stop fighting about something that's, for the most part, syntactical in nature? And that's where the CloudEvents project got started. Won't go into it here, but keep in mind that's where we're going to head to next. The other piece of work that we're doing is function workflows, and Cathy will talk about that later, but that's another piece of offshoot that says, can we look at sort of a standardization in this space? Because some people want to get involved in this, but they don't want to have to reinvent the wheel or redo their tech or redo their applications in that space just so when they go do different platforms. So can we standardize that as well? And Cathy will talk more about the workflow in a minute. But for now, let's go and talk about CloudEvents. So as I said, what we're looking to do is to standardize CloudEvents. Now, in the past, there have been many, many efforts around standardizing events. There are common event formats and stuff like that. And those try to be very ambitious. They really try to standardize the entire event structure down to every individual little property of the data model related to the business logic. And they had limited success, put it that way. We decided to take a different approach. We weren't going to try to standardize the entire cloud event itself. Rather, what we wanted to do is see whether there was common bits of metadata that we can extract from all events and say, let's agree on those. So for example, if you look at this example cloud event on here, you'll see things like source, ID, time, and content type. Those are describing the event itself, and almost every single event will always have at least those kind of properties, right? That's what we were shooting for. The base minimum set of properties that pretty much every single event is going to want to have in its message. Everything else is going to be reserved for data. That's where the business logic payload is going to go. And that could be free form, it could be anything you want as defined by the content type, okay? So if you look at this, what you're actually going to notice is this is actually very similar to something you guys should all be very familiar with, which is HTTP, right? If you think about HTTP, what did they do? They defined some common headers, and then they have a payload in the body. And that payload can be anything you want, that's where your business logic goes, but they define a common set of HTTP headers that allows you to, in a consistent and standardized way, send messages from one node to another, and you don't have to understand for every single payload what types of metadata and the format of that metadata just to get it from point A to point B. That's what our metadata is very much like, at least that's the way I think of it, is think of it as HTTP headers, but for events, okay? So it's just common events or common properties that are used to help get the message from point A to point B. Anything else related to the business logic is out of scope for the Cloud Event specification, okay? So we define a consistent set of metadata, a core specification that defines that bit of metadata, and then we have some transport specifications which says how do you serialize those common properties in different formats, in JSON, over HTTP, over MQTT, those types of things. Okay, so if you think about what we actually produced, it's actually very, very minimal because we want to try to make this as useful as possible in as many cases as possible, so we couldn't be too prescriptive. But in the same way HTTP is widely used with, in my opinion, a minimal set of definitions, we're following that exact same pattern here. And I'm not going to go into the exact properties because they're all relatively obvious for the most part, and you guys can read the spec. But keep in mind, this actually is a complete cloud event. You can see the minimal set right here, and even, to be honest, some of those are even optional. So we really, really kept it minimal. So what are the use cases that we're trying to solve with these types of things? Really, this is about interoperability. Can we normalize the event properties down to the bare minimum to help a message get from one point to another? Again, it's about interoperability. So it's about facilitating integration across platforms, and most importantly, stay out of the business of messing with people's business logic, right? Because if you go back to the previous slide, we don't touch data. Data can be anything you want. In this example, it's sort of JSON-ish. It can be anything you want in there at all. It doesn't have to be even JSON, it can be any kind of payload. We stay out of that line of work, right? Ours is just the bare minimum properties. And again, this is all about taking that first tiny step towards defining interoperability for functions in general. Just events was the first step in that process. We may look at other things in the future, like for example, Cathy's going to talk about workflow. That's another thing we sort of picked up. But there are more things that we've been thinking about. This is just the first step in that process. So what are we actually delivering? I talked about some of these already. The Cloud Event specification just defines the bare minimum metadata. We define a couple of serializations for different formats. JSON, obviously, a very popular one, so we define that one. AMQP is another one. We define a set of transport bindings. So for example, how did these cloud events actually appear over HTTP? We actually define two different formats for that. Structured, where that entire JSON I showed you earlier is in the body. A binary format where those cloud event properties appear as HTTP headers. And then the HTTP body is the equivalent of our data object, and that appears, that's where the business logic goes, right? So you can read the specs yourselves, but we chose some of the more popular transports out there to try to get as much adoption as possible. And finally, we have a primer, which is a non-normative document which just describes the design philosophy, some of the design decisions in terms of why we did what we did, just to give you some background in terms of what we're doing, why, and some reasoning behind some of the decisions, because some of them might be a little controversial. But the primer will help you understand why we made the decisions that we did, okay? Now, another piece of work that we're doing, and this is really there to not only aid in adoption, but to help make sure that what we're producing actually is usable, because we want people to actually use this in the real world. We're producing a set of SDKs. Basically, you can think of these SDKs as really aids in the serialization and deserialization of cloud events. So for example, in the Golang case, if I'm writing a Go program, I'll use the Golang SDK, give the SDK my cloud events, tell it to send over HTTP, and it will do all the magic for me, hopefully, to send over HTTP. This is still very much in not even alpha form yet. They've just kind of started the process. We are hoping that maybe by KubeCon Seoul, some of these, like the Go one or Java one, may be in an alpha stage by then, but it's still very much a work in progress, okay? You can see the languages that we're shooting for. The first three, Go, Java, and JavaScript, have been started. The other two, C# and Python, have yet to be started, but there are rumors that they will start very, very soon. So expect those to come out. If you guys are interested in participating and helping prove out the spec, this would be a great area for you guys to help out in, because this is one area that we really need some help on, just in terms of validating what we're producing from a specification perspective actually makes sense and works in your guys' use cases. And so with that, what I'm going to do now is hand it over to Cathy to talk about the status of Cloud Events and then get into workflows.
Okay, thanks. As some of you already I think some of you already know that we already released Cloud Events version 0.1 in April 2018. And the next version, 0.2, will come soon. And after that, we're going to work on the Cloud Events version 1.0. And in 1.0, we're going to finalize the core event attributes, which is metadata Doug mentioned before. And we're also going to finalize the set of particles and the serialization mappings. I think Doug mentioned some of those too. And we're going to produce some documentation so to help you, understand this and use it, such as developer guide, user guide. And then we're going to organize several interop demos to show how you can use these cloud events, and then to see how they work. Different implementations can work together through this standard specification. And after that, we will develop SDK and some supporting tools for the cloud events. So our concentration will be on stabilize this standard specification and also help with adoption of the cloud events format by organizing more interop demos. So now I'm going to give an introduction of the workflow. So what is a workflow? Most of serverless applications are not a simple function triggered by a simple event. I think probably most people are familiar with like Lambda, right? It's just one event trigger a function. Most serverless applications are composed of multiple steps of function execution. At each step, different events can trigger different functions. And different steps, there are different events trigger different functions. And those functions could execute in sequence or in parallel. And information may need to be passed from one function to the next function, or from one step to the next step, or from the event to the function. So a function workflow is actually a function execution flow. That's what we mean by function workflow. And this diagram shows an example function workflow. We can see that it involves multiple steps, and each step is associated with events and function, and it could be associated with multiple functions too, like the step 3. So why do we need a workflow standard specification? So today, application is developed and run in the application developer's own system. With introduction of serverless, the app developer's work is reduced to only writing the function logic, and all the other work is handed over to the serverless platform, such as monitor the event triggers, and deciding like how many containers or other compute resources to schedule to host and run those functions, and how to manage each step of the workflow, how to pass the information from one step to the next step, or how to filter the information during this information passing process. And also if the function returns a failure, how to do the retry. So since the serverless platform takes over all the work, right, the serverless application developer needs to give a workflow description or template to the serverless platform so that the serverless platform knows how to manage and execute this workflow. So we need a standard specification for the different application developers to specify the workflow template. And that workflow template can be used by different cloud serverless platforms. If we do not have such a standard specification, then the application developer has to write maybe many different types of workflow specification or workflow templates. So our goal of the workflow specification is to provide a standard way for the user to specify the function workflow for their serverless application, so as to facilitate portability of your application across different vendors' platforms. I want to clarify that it is not, the workflow specification is not a specification for function signature, such as specify what kind of language this function is written, what's the memory size for the function. So it's not for that. That we need a separate spec for that. It is also not a spec for specifying the detailed event information, like the event format or metadata definition. That's specified by the CloudEvents specification. So in detail specifically, the workflow specification scope includes the following. It provides primitives for the app developer to specify the steps, or you can call it states, involved in a serverless application workflow. It provides primitives for the app developer to specify what event will trigger what function in the workflow. It also provides primitives for the app developer to specify the functions in each step, how many functions, how those functions should be executed. It also provides the app developer the primitives to specify how information should be passed or filtered from one function to the next function or from one step to the next step. It also provides primitives for the app developer to specify the retry the serverless platform should do if an error happens. So this slide shows some information about the workflow specification. We have output the first draft of the specification, but this is just a draft. So we welcome more people to join this work group, to join the effort of working on this workflow specification. If you have any questions or you feel there's an issue, you're welcome to go to the GitHub and create a pull request for the issue. Of course, you're all welcome to contribute to the spec, to make it work for all your use cases. And so the second slide is a workflow spec link, and the third bullet is a serverless work group link, which has information on all the work we have done. Okay, I'm going to hand over to Doug.
We're going faster than I expected. So what I want to first talk about is a demo that we did at Copenhagen. I think it was CNCF Copenhagen. What is Austin's last name? Do you remember? Austin Collins from serverless.com did a really wonderful demo. The link to it's on YouTube. And what he did, Austin presented the demo. It was a group collaboration. Basically what it was is an event producer. So in this case, we had two different blob stores, AWS and Azure. They would produce an event, and each one would go through a different gateway. And then each of the various serverless functions out there, you got basically every single company, all the major players there, IBM, Google, Microsoft, Huawei, Red Hat, all the major players you could see on there, all ended up receiving these events. And what they ended up doing was taking the event in, and the event was basically the notification of a new image being uploaded into the blob store, and they're all being sent as cloud events, right? So these notifications or events are being sent out as cloud events, go through the gateway to the serverless function, which would then process the event to make sure everybody could process a cloud event successfully, right? To make sure it gets that interoperability statement. And then to prove that they processed it correctly, they would then tweet something to Twitter, obviously, either a message about the image. So in some cases, they would do some sort of visual recognition to try to guess what's in the image. In other cases, they would actually modify the image, then upload the picture to Twitter, and they had some fun with it. So what ended up happening was On Twitter, what you'd see is a couple different things. Like, for example, in the IBM case, it'd say Watson thinks it's a picture of a cargo door. Okay, did a pretty good job there. But then you have other people like Oracle who really had some fun with it, and we uploaded a picture of Dan Kahn, CEO, CTO, or executive director of CNCF, and they what ended up doing is sticking something smoking and then glasses on them, right? So people had some fun with this. But the point of this was to, again, showcase interoperability of cloud events across all these different platforms to make sure everybody could handle it properly. And it was actually starting to prove that cloud events actually are useful from an interoperability perspective. Now, since I think we have time, what I wanted to do was show you guys, down here is a link to the Twitter feed. So actually, I think it's still up there. You can actually look at the Twitter feed of all the old images we put up there and see some of the fun things. Because some of the visual recognition things are really humorous in terms of what some of the AI machinery thought was going on in the picture. Now, this is just a preview of what we're going to actually be doing for real in KubeCon Seattle. But I wanted to showcase some of the work that people have been doing. Again, this is all about interoperability of cloud events. So in this particular case, for those who aren't familiar, there's a game called Mad Libs, or it's a game, I guess, where someone randomly comes up with a sentence and they replace words in it, like nouns and verbs and stuff. They leave them blank. And then they ask somebody to give them a random noun, verb, adjective, and they fill it into the sentence. And because the user doesn't know what that, or because the person doesn't know what that sentence is, they come up with some really funny sentences. So what we did here is we had a variation of that. In the middle, we have a cloud event controller, which would generate an event saying it found a blank in a sentence, and the blank is supposed to be filled in with a verb, or a noun, or an adjective, or something like that. And it would send out that event to these various nodes that are subscribed to those events from the cloud event controller. Those nodes would then generate a random word fitting that category, noun, verb, adjective, and then would generate another event that would go back to the cloud event controller who subscribed to those guys to see what words they produced. In this particular case, the controller will wait up to, I think, 5 seconds or so to see what events came back in before it starts filling in the sentence with a random word from everybody that actually generated an event. So hopefully this will work. Let's see. Where's my cursor? Over here. So you'll see the events go out. And notice the timing is a little funky because what's happening is some cloud event infrastructures actually have a little bit of a delay time when they first start up. But if you run it again, this time it should go faster because they didn't have that initial delay for startup time. So this goes into the whole notion of how serverless frameworks work, right? Some of them are very quick because they have very quick startup times, or they're a little slower for that initial time. But then you guys see what happened here, right? You got every node generated a set of words, and then the controller randomly picked one. So for example, it picked John from VMware Dispatch. It picked, I can't read that in red. What does that say? Proud. Oh, proud from the IBM node, and then went back to here, picked equipment, so you get kind of a funny sentence up there. Now, the other interesting thing is, where's my cursor? There we go. So let's go ahead and click on this one. Well, you can actually, it's kind of small, but if you actually click on it, you can actually see we send the cloud event in binary format. This is HTTP. I know you guys in the back of the room can't see, but the cloud event properties are all HTTP headers, all prefixed with CE, standing for cloud event. But in this particular case, the event that he generated that the cloud event controller subscribed to, this is the structured format, meaning the cloud event is in the HTTP body with the data being the actual application logic, which is just the word that he generated. So again, this shows the two different formats for HTTP, binary and structured, proving interoperability between two different endpoints for sending and receiving cloud events. Okay? So anyway, just a demo of what we're planning on showing for real in KubeCon Seattle later this, I guess, next month. So with that, a little bit early, but we are taking out of time. What I want to do is give you some links for more information. Serverless Working Group, if you're interested in that. Technically, the Serverless Working Group actually isn't doing a whole lot right now because their work is pretty much done. We produced the white paper, the landscape, and stuff like that. We are still working on the workflow project there, but it's almost a subgroup under serverless. But serverless itself is kind of finished as of right now, but workflow is just starting to pick up. So that work is still going on, as Cathy mentioned. The cloud event stuff, it is a separate project. It's actually a sandbox project now under CNCF with some links there to the main site, the repo and the org and stuff like that you can see. and a link to the SDKs. It's under the CloudEvent org, under GitHub, and the SDK dash, and then the language. Now, a little bit of an advertisement. So tomorrow, as I mentioned, Clemens and Cathy will be doing a deep dive on Cloud Events. So now we basically just barely touched the surface on this one, but they're going to go deeper on it, explain some more of the rationale, eventing versus messaging, what the difference and stuff like that. So that's tomorrow at, 3:05. But then Cathy also has a session that's going to go deeper into the workflow stuff at 12:15. So you might, if you're interested in workflow, definitely try to attend Cathy's session tomorrow on that. Okay? Unfortunately, I didn't include the room for Cathy's. I apologize. You got to look at the schedule for that. But it's at 12:15. And with that, I think we're basically done. And we have time for questions. Yep. Don't be shy. I know you can't ask one, Clemens. And you can't either, Scott. He's another working group member, Scott from Google.
Yeah. So, okay, there.
Oh, the microphone. It's on? Wait.
Okay. Your voice.
Wait, is it on?
Wait,
Here, tell you what, this. Here, talk to this.
Okay, so I think the workflow standard depends on the function signature standard. So if you don't have any function signature standard, so how do you call a function in the workflow specification?
Okay, so that's a good question. You can hear me, right? Okay. So in the function, so we leave the function detail definition in the function signature definition. And in function workflow, we only reference as a function, you can think of it as unique ID. That's it, And then we're going to retrieve that from that unique ID, of course, the back-end implementation, right? You're going to retrieve that ID, and then you know what kind of, what language, what's the memory requirement, all those informations. But the purpose of is we do not want the workflow to dive into the detail of the function definition. So that's a separate document, yeah. But definitely that's needed. You're right. If without that, right, you cannot put together a whole solution. Yeah.
Any other questions?
Yeah, don't be shy. You can speak in Chinese. I can help translate.
Okay. It's on.
Hi, thank you for the talk. So this is also under the CNCF, but there's another one called Knative, also under this one. How you relate these two projects?
You want?
Yeah.
Okay.
Well, no, go ahead.
So Knative is an open source project, right? I think we have Nicholas, from Google. He's working on Knative. He also joins this work group. I think there will be a cooperation. So that's an open source project. This is more currently, at least currently, we're defining the standard. So I think the Knative will look at the standard defined in this work group and see, how they can adopt this, right? And also, hopefully, they can give us some feedback. Say, okay, this spec you're missing some information, or something like that, or maybe. Nicholas, you want to answer?
Well, Knative is planning on trying to support Cloud Events, right?
Yeah.
Knative is a function as a service or serverless framework or hosting environment, whatever you want to call it. This is just the spec for the event format itself. So Knative will use Cloud Events as part of its infrastructure, or as part of the events that it can support, is the plan.
Excuse me, just to follow up a little bit. My quote-unquote so-called unqualified worry is that when earlier Doug talked about this, is this working group is I think you claim that other than a subgroup in workflow, every other work is done, whereas Knative is just getting started. So I'm kind of
right. So keep in mind that right now we obviously looking at events. Workflow is another one. When we first started, we were just doing events, right? workflow came up as we realized we were sort of nearing maybe the midpoint for cloud events. We realized, okay, maybe we start looking a little more forward. That's when we had a discussion, took a vote, and said, okay, workflow is the next one we want to start looking at. I expect there to be other things popping up on our radar to look at possible standardization. Don't know for sure what they're going to be. Chances are there obviously will be in the serverless function space, maybe function signatures, Cathy mentioned that, other types of things in the area. Just because the serverless working group isn't doing a whole lot right now doesn't mean it's dead. It's still very much alive, and I look at it as being sort of asleep right now. Once Cloud Events sort of finishes up, maybe workflow gets a little bit further along, then we'll find the next thing to wake it up, figure out what we're going to do next, spin off another working group, serverless will go back to sleep, and we'll have another working group to work on something. Assuming the CNCF Technical Oversight Committee says, yes, that's a good thing to look at. Okay? All right. Time for maybe one more question. Okay. I think we're done.
Yeah.
Good.
Thank you
guys
very much
for coming.
Thanks.